Cool. So we get a signal from our engine control system via which multi-purpose controller, gentlemen? Which multi-purpose controller is going to send a signal to our fever?
HCU.
Anyone disagree? Nope, that's correct. From the CCU, the cylinder control unit, because it is in charge of all our cylinder functions. So the signal is sent to the pilot valve, and we are going to do a fuel injection. So movement of a spool inside this pilot valve, allowing a pressurized control pressure oil to move the spool of the fever in this direction, and we are then going to allow pressure to the underside of our booster. At this point in time, we also close the drain of the underside here, so we are no longer draining from the fuel booster, but we are pressurizing to do an injection. But we will continue to drain, the blue line here, drain the pressure from the underside of our actuator, so no exhaust valve movement. When we've done an injection, then of course we'll have a signal to the pilot valve, and it will go to the center position, so still draining from the exhaust valve actuator, and now we will be also draining from our fuel booster. Remember, gentlemen, we're not draining oil, we're draining pressure. It is a fully flooded system, and of course we want to make sure that it stays fully flooded, so therefore we're removing any air. So we are moving pressure around and not oil. The movement of our plunger and actuated piston inside the booster back down to the 0 point is assisted by the fuel pressure on the top part of our plunger in the booster. When we're ready to do a exhaust valve operation, of course, the signal sent to the pilot valve will move, so we are able to drain any pressure from this point of our feeder valve, allowing the constant oil pressure to force the spool in this direction, closing off the drain from the from the exhaust valve actuator, opening up the supply, and then giving us a full system pressure to the underside of our exhaust valve actuator, charging the push rod, and we can see that we have the low pressure system coming in to the top side of our exhaust valve actuator, charging and opening the exhaust valve. Then, when we have done the exhaust valve operation, we will get a signal to the pilot valve again, or the control valve, moving the spool of the fever to the center position, and then we will drain again from the exhaust valve actuator and continue to drain from the fuel booster. The drain pressure is coming back down these two lines, and we have two orifice plates shown here, which is then slowing down the pressurized oil, because we're having low pressure line coming in, acting against the two, acting against the orifice plate, allowing then oil to flow this way. What do you think this is indicating, gentlemen? This point here. What do you think this is indicating? Nope. Okay, then this is our deaeration point. So this is the constant flow from our system. We can see we have a low pressure line coming in to flood the system. So we're expecting a drain from this side back down to the main tank to start the process all over again. Okay, so this is our deaerating point from the hydraulics unit distribution block. Cool. So we can see that we have the indication here of the double wall pipe, so we know that we're looking at one unit where the flange stops here. So therefore, when we continue on the line going through here, we will also see that we have this valve 560, which is the isolation valve for the lubricator here. So if we were to need to do any work or isolate the lubricator itself, we would close this valve, connect a mini-mesh connection to valve 565 shown here, and then we'll measure the pressure drop for the lubricator. But as you can see here, how do we release any pressure in this line here? Remember, when we close this valve, we still have whatever pressure is behind the lubricator here. How do you think we would release the pressure from the lubricator line? We're not talking about the cylinder lubrication, the cylinder lube oil. This is this side. We're talking about the hydraulic power supply pressure on this side. How do we bleed this pressure? Anyone?
Turn the engine.
Sorry, one more time.
Turn engine.
Turn the engine. Not quite.
Can we just do a few trial injections to the cylinders?
Trial injections. What else could we call that? Pre-lube? Yeah.
Yes.
We could carry out a pre-lube. You were right. I was just trying to fish for the name on the MOP screen. So we could go to the MOP screens, go to the cylinder lubrication folder, and we would carry out a pre-lube from there, and we would monitor the pressure drop on our gauge here. Once that is done, then we are assuring that the residual pressure is gone, and then we can start working on that system safely. Okay. Also remember, we would follow the instructions. What I haven't told you is also isolating the valves for your cylinder lubricating system, and so on and so on. That's something that you have to, of course, follow as well. So are there any questions to do with the 200 bar system? No? Pretty straightforward? Okay, so on the 300 bar system, again, I will try and zoom in. The drawings are as they are. There we can see this is a 200 bar system because the main pressure line coming in here is now a single line, so we don't have the double wall pipe anymore, and that is true to the fact now we have a single common supply and a flexible hose leading to the underside. So our pressure coming in to the underside of the hydraulic cylinder block, and then we're feeding up to the lubricator, and we have also kept the numbers of the valves the same, so all engine types will have 560 for your inlet valve for the lubricator. 420 is your main supply to the hydraulic cylinder. 421 is your main drain, and excuse me, 531 is the main supply for your low pressure line. So if you're looking at here, if you're doing any sort of work on the system, we're going to have a look at the accumulators now. Same principle for the 200 bar system as well. If we are going to do any work, we need to close the valve 420, connect mini mesh connection on the 455 point here, and then open 420, and then measure and check the pressure drop in the system here. When we've done this, then we can remove the accumulator that needs to be overhauled, and what we would do is we would use a temperature reader, and we would be